Okay, so this is going to be question number 25 from Unit 8, Lesson 3, Day 2 homework. This is found on page 596, and we're taking a look at Course 3 of the Core Plus Mathematics book series. So the question says, to remember the meaning of the inverse sine function, many students say to themselves, the notation inverse sine means to find the angle whose sine is x. For example, inverse sine of 0.5 is equal to 30 degrees, or pi over 6, because in a 30-60 degree right triangle, the side opposite the 30 degrees angle is, the 30 degree angle is 1/2 the hypotenuse. 1/2 the hypotenuse, or 1 over 2, opposite of hypotenuse. And it says, do you agree that this is a helpful and correct way to think about the inverse sine function? Well, what we like to do is think of the sine function as taking the sine of your angle being a ratio. So if the inverse sine function is doing the reverse, it's taking the ratio of 1 over 2 and working backwards. So it does make sense to do it this way for us, and so this is kind of your opinion, but I'm going to say yes to this because I feel like it's definitely allowing us to take the ratio and work backwards to an angle. You can say your opinion on this one though, so I'm going to write yes, but it's your opinion. Okay. Part B says, what does this way of thinking and the given drawing suggest is the value of arc sine of square root of 3 over 2, or inverse sine of the square root of 3 over 2? Well, what that's implying then is that the ratio of square root of 3 over 2 goes back to 60 degrees, right? So if we know sine of 60 is square root of 3 over 2, that means that this must be 60 degrees. And kind of nice, right? We talked about that earlier too, I believe in day 1 homework when we were using exact values. So if you missed that lesson, you might want to head back to the homework solutions for Unit 8, Lesson 3, day 1. But that does make good sense. C, what happens when you try to apply this way of thinking to find the inverse sine of a negative 0.5? Oh man, this is a little bit different, right? Because now I have a negative 0.5. And I might think, oh no, I can't have negative side lengths. But if you stop and think about negative side lengths in terms of a unit circle, then I don't have an issue. So let's get into the unit circle on this one. If I'm in the circle itself, then a sine of a negative 0.5, negative 0.5 is going to put you down here. This is a negative 0.5, because I know that's a negative 1 in the unit circle. That's a positive 1. I should put the coordinate 0, 1, and 0, negative 1. But the y values are what deals with sine. So I'm interested in this angle and this angle. Well, here's where some great symmetry happens. If I actually knew the solution to this problem, and my circle isn't great here, if I knew the solution problem to here of being 0.5, right, when positive 0.5, if I knew that angle, that's the same angle as it can be down here with a little bit of manipulation, all right? This right here has a 0.5 there, but this angle is now the same. Or if I go down to this part of the triangle, this is negative 0.5 now, but that angle is still the same as that one was, but it's down from 180 degrees or down from pi. And then one more time, if I go over here, that angle is the same too. And so I actually get out angle measures that will make sense here. If I knew 0.5 came out of this and that was a 30-degree angle, well, that means that this one down here, negative 30 degrees, would yield a negative 0.5. Or the part over here, right, which is 180 degrees counterclockwise plus 30 degrees more, or 210 degrees. Those are appropriate answers. We could also say that it's all full 360 all the way down and backtrack 30 degrees, which would be 330 degrees. Okay, so those are positive ways to write them, or if I wanted to go negative this way as well, I could go a negative 150 degrees. So you see there's different ways to write this, but the problem with thinking about the triangle with negative 0.5 is it doesn't fit the context of just looking at positive values of the side lengths. All right, but it would fit inside of a right triangle if I allow for the y values to be negative and the hypotenuse to be positive. So it does work out, kind of a neat problem. And then in part D, this expression says, what somewhat similar way of thinking about inverse functions can be used when you were asked to find the log of x? For example, to find the log of 1,000 or the log of 0.01. Well, what you can think of is the answer to this is 10 to that number that equals 1,000, right? So that's the inverse operation on this is the base 10 logarithms. So you think to yourself, 10 to what number is going to equal 1,000, then that will be the solution to the logarithm problem. So that in this expression, I know that 10 to the third is 1,000, so the answer to this would be 3 if I'm dealing with x here. And if I set this equal to x, I could think what x value will make 10 to what value would be 0.01. I know that 0.01 is 10 to the negative 2. Therefore, the x value to this would be equal to negative 2. So there's a good connection here between an inverse and its, well, a function and its inverse, and going from inputs to outputs and outputs to inputs. Don't be afraid of negatives when it comes to circle. I know that the negative signs for a triangle might look a little challenging, but they do fit inside of a circle. All right, that ends the day 2 homework for Unit 8, Lesson 3.